All right, so here's a video on taking basic derivatives when you have the variable to an exponent. All right, so this is what we're taking the derivative of, and this is what we're taking the derivative with respect to. All right, so x to the n. Now this is the formula that is in the AP Physics calculus equation sheet. All right, so that's why I'm working on this specific one, and it tells us what to do. So if we have just a simple one, x squared, all right, we can see that x squared is in this form, and that's the key when you look at the equation sheet that I'm going to be referencing. You have to recognize the form so that you know what procedure to do. All right, so we have our x and our x, and 2 represents the n. So it says here, we bring the n, which is the 2 in this case, down front, and we subtract, we still have x, we subtract the n by 1. So 2 minus 1, and we get, dx of x squared is equal to that. There's our formula. So we can see that the derivative is therefore equal to 2x. All right, very, very easy to do. All right, let's do another one. If we switch it over to something like physics, where we have x is equal to 3t cubed minus 2t squared plus t. All right. Now it's multiple parts, but each part has that form. So the ddx can be distributed through there when you can do each one of these individually. All right. So we'll take the derivative with respect to time, and we do that for each one of these individually. So this comes, so 3 comes down as multiplied by a thing out in front. All right, that you didn't see that here because what's out in front, this is a 1. All right, there's a 1 there, so 1 times 2. In this case, it's 3 times 3 is 9. That cube gets reduced by 1. Minus 2 times 2 is 4. That t gets reduced by 1. And this one is like having t to the 1. So if we reduce that plus t1 minus 1, we see that we get 9t squared minus 4t plus this is 1. Or sorry, 0. All right, sorry, kind of a long day. So anything to the, that this whole thing here is t to the 0. Anything to the 0 power is 1. All right? Now, if you have another problem where, let's set up, kind of in terms of physics, x is equal to, let's say, 5 over t cubed. Well, we can't integrate this because it's not in this form. It's not in the x to the n form. All right? But we can put it in that form if we rewrite it. So we're never going to do any calculus with fractions. We're always going to put in the forms we need. So this would be 5t to the negative 3. Now we have it in this form. All right, we have our t and we have our exponent. So from there, it's still just the same thing. Don't be confused by fractions. You just got to put the fractions in the form that we need. So x is equal to negative 15t. Now, don't just reduce the number. It's very easy to do that. Make sure you subtract. So negative 3 minus 1 will be x equals negative 15t to the negative 4. All right, t to the negative 4. And there's our final answer. And that's how we take the derivative of variables that are on the bottom. They're on the denominator. We actually don't. We rewrite it in a form that we know. Okay? And that's the basic, easiest derivatives that we're going to take. All right. If you look at the at this guide here, that we're not going to worry about this. We're going to we started right here. All right. Assuming you can see that, and that's what this example video is on. All right.